Good afternoon, everyone. Today I will be speaking on smart sensors and their daily life applications. Sensors are often actually described as the eyes and ears of modern technology, silently monitoring, collecting, and transmitting data to enable intelligent decision making. With the advent of IoT and AI and embedded systems, sensors have transformed from passive devices to smart systems capable of self-calibration, context awareness, and real-time communication. For the moment we wake up until we go to bed, smart sensors are seamlessly integrated into our daily lives, be it in the fitness tracker on our wristwatch, then the temperature and humidity sensors ensuring home comfort, then automotive safety sensors preventing the accidents, or healthcare monitoring devices that support well-being. They not only enhance convenience and efficiency but also improve safety, sustainability, and quality of life. In the next few minutes, I will briefly explore how these smart sensors function, highlights their key application across different domains such as healthcare, transportation, smart homes, and industry, and finally touch upon the future trends shaping this exciting field. Now I will now move on to my presentation, which is focused on the smart sensor and their daily life applications. Now, this is the outline of my presentation. The first, I will discuss the introduction section. After that, key features of smart sensors, then types of smart sensors. Then after that, I will discuss the smart sensors in daily life, then application of smart sensor, smart home, then application of smart sensor, that is healthcare, application in transportation, then application in environment and industry. After that, I will discuss the advantages of smart sensors, then challenges in smart sensors, and the future trends of smart sensor. And finally, I will conclude my presentation. Let starts with an introduction. So first I will highlight what is smart sensor. A smart sensor is an advanced sensing device that not only detects and measure physical quantities like temperature, pressure, motion, light, gas, etc., but also has built-in processing, communication, and decision-making capabilities, or it is a combination of sensing, processing, and communication on in one device. It enables real-time data collection and decision making, and integral to Internet of Things and smart systems. Unlike traditional sensors that only generate raw data, but smart sensor can collect data from the environment. It can process the data using embedded microcontroller or chips and communicate. It can communicate with data wirelessly by using some latest technology. I think Bluetooth is very older one, like Bluetooth, Wi-Fi, then Zigbee, etc. This such kind of technology, it can communicate with different devices, and it can make a decision or trigger action without any human intervention. That is the beauty of smart sensor. It can collect, not only collect the raw data, it can process those data by using embedded microcontroller, and it can filter out some unwanted noise and unwanted data and finally it communicate with data where it can communicate with different devices wirelessly, and finally it can make a decision without any human intervention. That is the beauty of smart sensor. Now coming to the next slide, I'm going to discuss the key features of smart sensor. uh, the first feature is high accuracy and sensitivity. Then second is self calibration and diagnostic. Third one is wireless communication, Bluetooth, Wi-Fi and Zigbee. And fourth one is low power consumption. And fifth one is compact and integrated design. So first I will discuss high accuracy and sensitivity. It is one of the most important feature of smart sensors is their high accuracy and sensitivity. So what do you mean by accuracy? Actually, accuracy refers to the ability of the sensor to provide readings that are close to the true value of the measured parameter. Smart sensors also achieve high accuracy through advanced signal processing techniques, precise calibration, and compensation for environmental factors such as temperature and humidity. And the sensitivity. So what is the meaning of sensitivity? Sensitivity actually describes the smallest change in the measured parameter that the sensor can detect. High sensitivity is crucial in applications where even small variation need to be monitored, such as environmental monitoring or medical diagnostics. In generally in traditional sensors often actually lack the sophisticated signal processing capabilities of smart sensors, leading to lower accuracy and sensitivity. So smart sensor actually employ algorithms, advanced algorithm, AI based algorithm to filter the noise, correct for non-linearities, and compensate for drift, resulting in more reliable and precise measurement. Then second one is self-calibration and diagnostics. So what is the feature of self-calibration and diagnostics? Smart sensors are equipped with self-calibration and diagnostic capabilities which enhance their reliability and reduce the need for manual maintenance. So what is the meaning of self calibration? Actually, smart sensor can automatically calibrate themselves to maintain accuracy over a time. This involves using internal reference standards or algorithm to adjust the sensor output and compensate for drift or aging effect. So self calibration ensures that the sensor continues to provide accurate reading without requiring frequent manual calibrations. So now I'm going to discuss about the uh, self calibration already have covered, and what do you mean by diagnostics? So smart sensors can perform self diagnostics to detect potential faults or errors. So this includes monitoring internal parameters such as voltage levels, temperature, and signal integrity. Okay, so if a fault is detected, the sensor can issues a warning or alert, allowing for timely maintenance or replacement. So this is one of the biggest feature of AI feature in the smart sensor. So these features are particularly valuable in remote or inaccessible location where manual maintenance is difficult or very costly. So maintenance is difficult and costly, and mainly it is used in some remote areas. Like I can tell you one example, like in high tower building or high in our BTS. base station, where frequently we cannot maintain frequently. So for that, such kind of cases, we can use these facilities. So self-calibration and diagnostics actually reduces the downtime, and it improves the data quality and lower the overall cost and ownership. Now next, coming to the wireless communication or Bluetooth or Wi-Fi and Zigbee protocol. So wireless communication is defining the feature of smart sensors, enabling them to transmit data wirelessly to central monitoring system or network. So some common wireless communication protocol actually used in smart sensor, that is Zigbee, Bluetooth and Wi-Fi, already I explained. So wireless communication actually eliminates the need for wired connections, making it easier to deploy sensors in remote or difficult to reach location. It is also enable real-time data monitoring and control, allowing for fast response time and improve the decision making. Then next one is low power consumption. So low power consumption is a critical feature of smart sensors, especially in applications where sensors are battery powered or need to operate for extended periods without maintenance. Then next one is compact and integrated design. So smart sensors are characterized by their compact and integrated design, which combines the sensing element, signal processing circuitries, and communication interface into a single package. The compact and integrated design for smart sensor makes them very easy to deploy and integrate into various applications. It also enables the development of new and innovative sensing solutions that were not possible with traditional sensors. For example, wearable sensor for health monitoring, implantable sensor for medical diagnostics, and embedded sensor for industrial automation. Coming to the next slide, the types of smart sensor. I have mentioned few smart sensor, but for example, but there are a few more number of sensors are available. More than 100 smart sensors are available in the market. So here I have mentioned few of them. So first one is temperature and humidity sensor. Then second one is motion or proximity sensors. Then third one is pressure sensors. Okay. Then image and vision sensors. Then biosensors and health sensors. Then gas and environmental sensors. So these are the different types of sensors, smart sensors. So what is temperature sensor and humidity sensor? The temperature and humidity sensors are fundamental component in a wide array of application, from environmental monitoring to industrial process control. So these sensors measure the degree of hotness or coldness of an object or environment and the amount of water vapor present in the air. The temperature sensor, actually this temperature sensor comes in various forms, including thermistors, then resistance temperature, then detector RTD, is called RTD, then thermocouple infrared sensor. Okay, so these are the different types of humidity sensor. So this sensor actually measures the amount of moisture of the in the air. Common types includes capacitive humidity sensor and resistive humidity sensor. So capacitive humidity sensor, this kind of sensors measure the humidity by detecting the changes in the dielectric constant of a polymer film. They are widely used in HVAC system and weather stations. And resistive humidity sensor, this sensor measures the humidity by detecting changes in the electrical resistance of hygroscopic materials. They are cost effective and suitable for general purpose humidity measurement. Now the applications. So mainly it is used in HVAC systems, which basically used to control the temperature and humidity for comfort and energy efficiency. Then next one is weather monitoring, collecting data for weather forecasting and climate studies. Then industrial processes, basically used to monitoring and control the temperature in manufacturing process. Then agriculture, it is used to monitor the soil temperature and humidity for optimal crop growth. Then healthcare, in healthcare sector, monitor basically used to monitor the patient body temperature and humidity in incubators. Next one is motion and proximity sensors. So motion and proximity sensors detect the presence of movement of object within a specified range. So these sensors are crucial for automation, security and user interface application. So motion sensor, this sensor actually detects the movement in an area. Some common type of motion sensors are available in the market, which is known as passive infrared sensor, then microwave sensor, then ultrasonic sensors, then proximity sensors. Okay, and this sensors actually detect the presence. Proximity sensor, what is the function of proximity sensor? These sensors detect the presence of object without physical contact. Common types, some common types include inductive proximity sensor, capacitive proximity sensor, then photoelectric sensor. The application of proximity sensor basically used in security system, detecting intruder and triggering alarms, automatic doors, opening doors automatically when someone approaches. Then in lightning control, basically used to turning the lights and off based on occupancy. Then in robotic application, basically used to navigate the robots and avoid some obstacles. And automotive, it is used to detecting the vehicle in blind spot and assist with parking. Now coming to the next slide, that is pressure sensor. Pressure sensor measure the force exerted by a gas or liquid per unit area. They are essential in various applications including automotive, medical and industrial settings. What are the types of pressure sensors are available in the market? Strain gauge pressure sensor, then capacitive pressure sensor, then piezoelectric pressure sensor. So what is strain gauge pressure sensor? This sensor used to strain gauges to measure the deformation of a diaphragm caused by pressure. They are widely used in industrial pressure measurement. The next one is capacitive pressure sensor. This sensor actually measure the pressure by detecting the changes in the capacitance of a diaphragm. They offer high sensitivity and are used in medical devices and automotive applications. Next one is piezoelectric pressure sensor. This sensors generates an electrical charge when subject to pressure. They are used in dynamic pressure measurement, such as in engine combustion analysis. Now, where is the application of pressure sensor? Mainly used in automotive industry, medical industry, then industrial automation, aerospace industry, then weather monitoring, weather forecasting area. So in automotive industry, mainly used to monitor the tire pressure, then engine pressure and brake pressure. Then in medical domain, measuring blood pressure and respiratory pressure. Then in industrial automation, basically used to monitoring the pressure in pipelines, then tanks and hydraulic systems. In aerospace, basically measuring, mainly it is used for measuring the altitude and airspeed. And weather forecasting, it is used to measure the atmospheric pressure. That is the function of pressure sensor. Next one is coming to image and vision sensor. So image and vision sensors capture the visual information and convert it into digital data for processing. So these sensors are fundamental to computer vision, then robotics and surveillance systems. Now the types of image and vision sensor. What are the types of image and vision sensors are available in the market? The first one is CCD. I think everybody knows about this. This is called charge coupled devices. Then CMOS stands for complementary metal oxide semiconductor sensors, then infrared camera sensors, then 3D camera sensors. So what is charge coupled device sensor? These sensors convert light into electrical charge and transfer the charge to an amplifier, and it offers high image quality and are used in scientific imaging and professional cameras. Then next one is complementary metal oxide semiconductor. Uh, this sensor actually complementary metal oxide semiconductor sensor mainly used to integrate the light sensing elements and the signal processing circuitry on a single chip. They are cost effective and widely used in smartphones, webcams, and security cameras. Then next one is infrared cameras. So these cameras are these cameras detect the infrared radiation and create images based on temperature differences. They are used in thermal imaging, night vision, and security applications. So next one is 3D cameras. So what do you mean by 3D cameras? These cameras capture the depth information in addition to color and intensity. They are used in robotics, then gaming and augmented reality application. Now, where is the application of this image and vision sensor? Mainly, it is used in surveillance. Surveillance means to monitoring the areas for security purpose. Then, in robotics application, in robotic application, mainly it enabling the robots to navigate and interact with their environment. Then automotive industry, it assisting with driver assistance system, ADAS system, such as lane departure warning or automatic emergency braking system. Then medical imaging system, it is actually capturing the image of internal organs for diagnosis. Then next one is quality control. It is used to inspecting the product, whether the product is genuine or some defects are there. So that is the function of image and vision sensor. Coming to the next slide, the biosensor and health sensor. So biosensor and health sensors detect the biological or chemical substances and physiological parameters. They are crucial for medical diagnostics, environmental monitoring, and food safety. So this type of biosensors and health sensors, uh, the types of biosensor and health sensor I will discuss about this. So there are several types of biosensor and health sensor available in the market. The first one is electrochemical biosensors, then optical biosensors, then wearable health sensors. Okay, so what do you mean by electrochemical biosensors? So this sensor actually detect the changes in electrical current or voltage caused by biological reactions. They are used in glucose monitoring, then DNA detection and environmental monitoring. Second one is optical biosensor. So this sensor detect the changes in light absorption, uh, fluorescence or refractive index caused by biological reactions. They are used in drug discovery and protein analysis and pathogen detection. And wearable health sensor, the sensor monitor the physiological parameters such as heart rate, blood pressure, activity level. They are used in fitness tracking, then remote patient monitoring, and early disease detections. Now coming to the application side of biomedical sensor, see mainly it is used in medical diagnosis, detecting diseases and monitoring the patient health. Then it is used in environmental monitoring. It is mainly used to detect the pollutants and toxins in the environment. Then in food safety area, it is used in food safety domain for detecting pathogens and contaminants in food. Then drug discovery, just now I told, screening potential drug candidates, and personalized medicine, tailoring treatments to individual patients based on their genetic makeup and physiological parameters. These are the application of biosensor and health sensor. Coming to the next slide, now I am going to discuss the gas and environmental sensor. So, what do you mean by gas and environmental sensor? Gas and environmental sensors actually detect the presence and concentration of various gases and environmental parameters. They are essential for air quality monitoring, industrial safety, and climate control. Now, what are the types of gas and environmental sensors are available? So in the market, that is electrochemical gas sensor, there is semiconductor gas sensor, particulate matter sensor, then light sensor. Now I will discuss one by one. So what is the meaning of electrochemical gas sensor? So this sensor actually detects the gases by measuring changes in the electrical current or voltage caused by chemical reactions. They are used in carbon monoxide detectors, oxygen sensors, and nitrogen oxide sensors. Now, next one is semiconductor gas sensors. So, this sensor actually detects semiconductor gas sensor basically detects the gases by measuring the changes in the electrical resistance of a semiconductor material. They are used in volatile organic compound, which is called known as VOC detector, and alcohol sensor and methane sensor. These are the electrochemical, semiconductor gas sensor. Now, third one is particulate matter sensor. So this sensor actually measure the concentration of particulate matter in the air. They are used in air quality monitoring and pollution control. Now, the last one is light sensor. So this sensor actually measure the intensity of the light. They are used in agriculture, then a smart lighting and environmental monitoring system. Coming to the application of gas sensor, so it is used for air quality monitoring, measuring pollutants and toxins in the air. For industrial safety, it is used mainly used to detecting the hazardous gases in industrial environment. Then another application is climate control. Mainly it is used to monitor and control the temperature, humidity, and carbon dioxide level in a building. Then agriculture. It is basically used to monitor the environmental condition for optimal crop growth. And in the automotive industry, mainly it is used to detect the exhaust gases and controlling the engine emissions. That is the application of environmental monitoring sensor, gas or environmental sensor. Now coming to the smart sensor in homes. So smart home are becoming increasingly popular, and smart sensor at the heart of this trend. This is our latest trend. They actually enable the automation, improve the energy efficiency, and enhance security. So the first important home sensor is smart thermostat. Okay, so what do you mean by smart thermostat? Smart thermostat actually used for temperature sensor. It is used to temperature sensors and occupancy detectors to learn your heating and cooling preference and automatically adjust the temperature accordingly. This can lead to significant energy savings and instead increase the comfort. For example, a smart thermostat can lower the temperature when you are away from the home. When no one is available in the home, then that sensor automatically make it lower the temperature. And when the occupancy in one single room is more, automatically it will cool down the room. That is the that is called smart thermostat sensor. So nowadays most of the air condition are implemented with the help of smart thermostat sensor with fuzzy logic technology. Then coming to the next one is that is smart lighting. So smart lighting system used in light sensor and motion detector to control the lights in our home. Okay, so they can automatically turn lights on uh, when we enter into a room and off when we leave from that room. So in some systems can even adjust the brightness of the light based on the ambient or light level. Okay, so this kind of features are available everywhere nowadays. Most of the smart home, if you see this kind of mainly in shopping mall or any some standard hotel, five-star hotel, you will get such kind of features. Then smart security systems. Okay, in security systems. So smart security systems use a variety of sensors, including door and window sensors, motion detectors, and camera to protect to our home from intruders. This system can send alert to our smartphone if a security breach is detected, and some can even automatically call the police. Next one is leak detection. I am discussing this kind of sensor. It is there are so many sensors are available, but these are the few glimpses I am discussing, few sample of discussion. So this is another sensor that is called leak detection sensor. So mainly it is used to detect the water leak, can detect the leak in our plumbing system and it alert us before they cause significant damage. So this sensor can be placed near water heater or washing machine and other appliances that are prone to leak. Okay. Now, smart sensor in workplace. This is very trending. This one. So, smart sensors are also transforming the workplace, making it more efficient, comfortable, and safe. So, the first one is occupancy sensor. So, what is the function of occupancy sensor? Occupancy sensor can be used to control lighting, heating, and cooling in office buildings by automatically turning off lights and adjusting the temperature in unoccupied areas. So these sensors can help to reduce energy consumption. Next one is air quality monitoring. Air quality sensor can monitor the level of pollutants in the air and alert building managers if the air quality is poor. So this can help to improve the health and well-being of employees. Then asset tracking. So asset tracking sensor can be used to track the location of valuable equipments and assets within workplace. So this can help to prevent theft and improve the inventory management. Then next one is environmental monitoring. So environmental monitoring sensor already have explained can monitor temperature, humidity, and other environmental condition in the workplace. So this can help to ensure that employees are working in a comfortable and safe environment or not. Next, coming to the smart sensor in vehicles. So, smart sensor are essential components of modern vehicles, enabling advanced safety features, improving fuel efficiency, and enhancing the driving experience. So, first one is called anti-lock braking system (ABS). So ABS uses wheel speed sensor to detect when a wheel is about to lock up during braking. If a wheel is about to lock up, the ABS system will automatically reduce the braking force to that wheel, allowing the driver to maintain control of the vehicle. Next one is electronic stability control. So ECL, ESC. ESC use a variety of sensors including wheel speed sensors, steering angle sensors and yaw rate sensors to detect when vehicle is starting to skid. If the vehicle is starting to skid, the ESC system will automatically apply the brakes to individual wheels to help the driver regain the control of the vehicle. Then adaptive cruise control, that is known as ACC. Mainly ACC uses the radar sensor to maintain a safe following distance from the vehicle in front. The system will automatically adjust the vehicle speed to maintain the set following distance. Next one is blind spot monitoring. So blind spot monitoring systems use the radar sensor to detect vehicles in the driver blind spot. If a vehicle is detected in a blind spot, the system will alert the driver. Coming to the smart sensor in healthcare. So smart sensors are actually revolutionizing the healthcare, enabling remote patient monitoring, improving diagnosis and enhancing treatment outcomes. So already I have discussed about the wearable sensor, so I will not discuss in detail. Next one is implantable sensor, that also I have covered. Then remote patient monitoring, this is very important. So remote patient monitoring system basically use sensor to collect data from the patient in their homes, and this data is the transmitted to the health care provider who can monitor the patient's condition and provide timely interventions. And diagnostic image, smart sensor are actually this kind of sensor are used in variety of diagnostic image techniques such as MRI, CT scan. So this sensor help to improve the quality of image and reduce the radiation exposed to the patient. And smart sensor in industry. So some smart sensor are actually widely used in various industries to optimize process, improve the efficiency and ensure safety. So the first one is predictive maintenance. So what is predictive maintenance? Actually, sensor can monitor the condition of machineries and equipment, detecting early sign of wear and tear. So this allows to proactive maintenance, preventing costly breakdown and downtime. Okay, next one is process control. So sensor are the in process control industry, mainly the sensors are used to monitor and control the various parameters in industrial process, such as temperature, pressure, and flow rate. So this actually ensures that the processes are running efficiently and safely or not. Then in robotics industry, so robots actually use sensor to perceive their environmental and interact with it. So this sensor includes we mainly vision sensor, force sensors, and proximity sensors. Sometimes tactile sensors also we are using in robotics application. And then next one is environmental monitoring. So a sensor can monitor the level of pollutants in the air and water, ensuring that the industries are complying with the environmental regulations. So next slide. So what are the advantages of smart sensor? So smart sensor actually revolutionizing the various industries and aspects of our daily life. Uh, these are the key advantage using smart sensor, focusing on increased safety and security, then energy efficiency, then real-time monitoring and decision making, enhanced convenience and comfort, and their support for automation and AI integration. So this benefits highlights the transformative potential of smart sensor in creating a more connected and efficient and responsive world. So it increase the safety and security. So smart sensor play a crucial role in the enhancing safety and security across the various domains by providing real-time data and intelligent analysis. So they enable the proactive measure to prevent the accident, then detect threats and protect assets like hazard detection and prevention, then security system, then structural health monitoring, then environmental health monitoring. Another second advantage is energy efficiency. So energy efficiency is a crucial concern in today's world, and smart sensor offer significant opportunities to reduce energy consumption and promote sustainability. So like smart lighting. So smart lighting system uses sensors to detect occupancy and ambient light levels, adjusting lighting accordingly. So motion sensor can turn lights on only when someone is present, while light sensor can dim lights when natural light is sufficient. So this reduces the energy waste and lower the electric bill. Then in HVAC control, so smart thermostat uses sensor to monitor temperature and humidity, optimizing the heating and cooling based on the occupancy patterns and user preferences. They can learn user behavior and automatically adjust settings to maximize energy savings. So in additionally, smart sensor can detect the inefficiencies in HVAC systems such as leak or malfunctioning components, allowing for timely maintenance and repair. Then next, another important advantage in smart sensor in terms of energy efficiency, smart grids. In smart grids, mainly use sensor to monitor energy consumption and distribution, optimizing the flow of electricity and reducing the waste. So smart meters actually provide the real-time data on energy usage, allowing consumer to make informed decisions about their consumption. In additionally, smart sensors can detect the faults and outage in the grid, enabling rapid response and minimizing downtime. Then next one is water management. Mainly the smart sensor can monitor water usage and detect leaks, helping to conserve water and reduce the water bills. Like flow sensor can track water consumption in homes and businesses, while soil moisture sensor can optimize irrigation in agriculture and landscaping. Then leak detection sensor can identify leaks in pipes and plumbing systems, plumbing systems, preventing water damage and conserving water resources. Coming to the advantage of real-time monitoring and decision making. So the ability to monitor conditioning in real time and make informed decision based on the data is the key advantage of smart sensor. Like in industrial automation, already I have explained. Then in healthcare sector, then supply chain management, then traffic management. So I will explain about the traffic management, how it is useful. The smart sensor actually monitor the traffic flow, detect the congestion, and optimize the traffic signals in real time. So traffic cameras can monitor traffic condition, providing data for traffic management system. The speed sensors can detect the speeding the vehicles, improving the safety. Then adaptive traffic signals can adjust timing based on the real-time traffic condition, reducing the congestion and improving the traffic flow. Then another advantage is enhanced convenience and comfort. When smart sensor actually contribute to enhance convenience and comfort in home, offices, and other environments, like smart home automation, which I already smart home automation actually have not covered. So I will explain few lines about this. The smart home automation sensor actually enable the automated control of lighting, then temperature and appliances, creating a more comfortable and convenient living environment. Like voice activated assistants can control the smart devices, allowing user to adjust the setting with the simple voice command. Then geofetching can trigger the action based on the location, such as turning on the lights when arriving home. So this simplifies the daily task and enhance our overall life living experiences. Then personalized comfort. So by using this smart sensor can learn user preferences and automatically adjust settings to create personalized comfort experience. So smart thermostats can learn preferred temperature settings and automatically adjust the temperature accordingly. So smart lighting system can adjust the lighting level based on time of day and user activity. So this creates a more comfortable and enjoyable environment. Now the next one is remote control. So smart sensor actually enable remote control of devices and systems, allowing user to manage their home and business from anywhere. So like smart locker can remotely locked and unlocked, providing convenient access for guest and service provider. Then smart security system can be remotely monitored and controlled, providing space of mind, peace of mind. So this provide a great flexibility and control over one's environment. There is another advantage of smart sensor, that is support automation and AI integration. So smart sensor provide the data necessary for automation and AI integration, enabling more intelligent and autonomous systems like in robotics. So in robotics, smart sensor are essential for robotics, providing robots with the ability to perceive their environment and interact with it intelligently. Like vision sensor mainly enable robots to identify object and navigate their surroundings. Then force sensor enable robots to manipulate the object with precision. So this enables robot to perform complex tasks in manufacturing, logistics, and other industries. Then autonomous vehicles. So smart sensor are critical for autonomous vehicle, providing them with the ability to perceive their surrounding and navigate safely. So LIDAR sensor, LiDAR sensor create the 3D maps of the environment. So this is actually one kind of radar sensor detect object in all weather condition. The mainly cameras provide the visual information. So this enables autonomous vehicle to drive safely and efficiently. Now the next one is AI powered system. So smart sensor actually provides the data necessary for AI powered systems to learn and make decisions. So machine learning algorithm can analyze sensor data to identify the pattern and predict the future events. So this enables AI powered systems to optimize processes, improve the efficiency, and enhance the decision making. So in conclusion, the smart sensor offers a wide range of advantages, including increased safety and security, then energy efficiency, then real-time monitoring and decision making, enhanced convenience and comfort, and support for automation and AI integration. As the technology continues to advance, smart sensor will play an increasingly important role in creating a more connected and efficient and responsive world. Now, what are the challenges in smart sensor? So the challenges in smart sensor, it is high cost of advanced sensor. So one of the most significant barriers of this widespread adoption of smart sensor is their high cost. So this cost stems from the several factors like complex manufacturing process. Okay, then the miniaturization. So the trends towards the small and more complex sensors necessities, sophisticated then microfabrication process, achieving high level of miniaturization while maintaining the performance and reliability can be expensive. Then the material cost. So some smart sensor utilize specialized material with unique properties such as high sensitivity or selectivity. So this material can be rare or require complex synthesis process, driving up the overall cost. Then calibration and testing. So in smart sensor, most of the smart sensor requires rigorous calibration and testing to ensure accuracy and reliability. So this process can be time consuming and require specialized equipment, adding to the overall cost. Then a low production volume. In some cases, the demand for specific type of smart sensor may be relatively low, leading to limited production volume. So this lack of economics of scale can further exacerbate the cost issues. Okay, now the mitigation strategies. So there are some strategies are there like standardization. So promoting the standardization in sensor design and manufacturing can help to reduce the cost by enabling mass production and component sharing. Then next one is advanced manufacturing technique. So exploring and adopting advanced manufacturing techniques such as 3D printing and flexible electronics can potentially lower production cost and enable the creation of more complex sensor design. Then material innovation. So in researching and developing new materials with improved performance and lower cost can help reduce the overall cost of a smart sensor. Then another important challenges that is called data privacy and cyber security issues. Then another important is power management in IoT networks, and after that environmental durability, that is heat, dust, moisture. So these are the challenges for smart sensor. Now, what is the future trends? Now, next slide, I'm going to discuss about the future trends in smart sensor technology. So, okay, like AI powered smart sensor is one of the promising area of research. So the integration of artificial intelligence with sensor technology is leading to the development of smart sensor. So this sensor go beyond simply collecting data. They can process, analyze, and interpret the information in real time, enabling more intelligent and autonomous decision making. Okay, so applications. So smart sensor are actually finding the applications in various fields, including healthcare, manufacturing, environmental monitoring, and automotive industry. There is another future trends integration with 5G and IoT ecosystem. Okay, useful for smart agriculture, industrial IoT, smart homes, and logistic and supply chain. Then nanotechnology based sensor. Mainly, it is this is another future trend that is nanotechnology based sensor is mainly used to detect the used for medical diagnostics, then environmental monitoring, food safety and security. Then next future trends is autonomous systems and robotics, mainly used for autonomous vehicles, drones, robotics, and agriculture. Then next one is smart cities powered by sensor network, mainly used in traffic management, air quality monitoring, then energy management, public safety, then waste management. Now, now I'm going to conclude my discussion. In conclusion, the future of sensor technology is characterized by the increasing intelligence, connectivity, then miniaturization, and integration with other advanced technologies. So these trends promise a transform various industries and aspects of our daily life, leading to more efficient and sustainable connected world. So thanks for this conversation and discussion. So thank you very much for this presentation. Thank you.